Hello everyone, today we're going to continue with the HCIA-Storage course. Previously, we covered the basic concepts of data storage, and now we will officially introduce the development history of storage technology. First up is the development of storage architecture. So what is storage architecture? This goes back to the 1950s. Speaking of the 1950s, the first hard drive back then was actually a mechanical hard drive. At that time, IBM invented the first hard drive, which had 50 24-inch platters, but how much capacity did it have? Only 5 megabytes. Its size was about the size of 2 refrigerators, and it weighed over a ton. But what? It only had a capacity of 5 megabytes, right? Just 5 megabytes, and it was independent of the main system. It was a standalone disk, a separate hard drive. This was the very first foundational hard drive. So moving on from there, by the time we got to the 1980s, what had already appeared? At that time, what had already happened? This had already appeared. We had some disks connected together. Or it was called a disk array back then. The main system actually saw it as a bunch of independent hard drives connected together. This kind of setup only increases capacity, but it doesn't really provide any basic guarantees or security. It just stacks some hard drives together, simply boosting the capacity. Then, as we move forward, what came next? We saw the emergence of network-attached storage. Later on, some network storage layers emerged. As for network-attached storage, it mainly involves connecting the disks of multiple servers through the network to form a storage network. This way, we can allow all the devices in that area to share our network storage. Moving forward, we reach this century, or let's say in recent years, what we commonly use now are distributed storage and cloud storage. These are the two that I use quite frequently: distributed storage and cloud storage. Distributed storage is actually when multiple servers come together to form a cluster. Within the cluster, we can freely allocate storage space, and we can also expand the capacity of our cluster nodes in real time. Expansion includes two aspects. The first aspect is expanding the disk space of each server. Of course, this is definitely limited. There's another way, which is to expand the nodes by adding new servers to our cluster. With this method, and after the emergence of distributed storage, theoretically, we won't be limited by the size of the disks anymore. Because theoretically, we can infinitely expand our nodes. As long as you have enough devices. And then we have cloud storage. We directly store the data on the fish. Through the network, we connect to some remote computer rooms to obtain our own data. This is the overall process of our storage architecture, from the initial very large mechanical hard disk to the size of our hard disk gradually becoming smaller, and then gradually we use multiple hard disks together, and then to the current one. Distributed storage and cloud storage, this is the overall journey of our storage architecture. So here, in our daily enterprise operations, we can currently use some disk-related technologies. First of all, let's get to know our disk arrays. This is very important. If, for example, your company does not have a lot of equipment or servers, we generally will not use distributed storage, and we will not be able to build storage. We still use traditional disk arrays as a method. So, what is a disk array? Here, let's take a moment to understand the basic concept of a disk array and its fundamental purpose. So first of all, we started out, in the beginning, it was definitely just one disk, right? At first, we had a CPU, memory, and some other basic devices connected to our hard drive. Connected to the hard drive. In the beginning, having one or two hard drives was already pretty good. Just being able to connect a hard drive was quite impressive. Then moving on. One disk is not enough. With the development of this technology, what can we do? we can connect some other disks to our server. So what are the benefits of external connections? First of all, we know that the server's disk has a slot limit. For smaller servers, you may only be able to install 4 or 8 disks, and for larger disks, you may only need a dozen or 20 disks. This is actually the limit for many servers. Many servers can only install a dozen or 20 disks. You can't add any more. So when all the disks are completely filled up, I'm running out of space. What should I do to expand? You've occupied all the ports. So later on, as the demand increases, right? The demand keeps growing, which actually drives the development of technology. Then we saw the emergence of early external storage. External storage. So what is an external storage device? Connecting what? Connecting an external device. Then within this device, we can add multiple disks. We can add several disks in this setup. The benefit of this setup is quite simple. We are not limited by the number of slots, which solves the problem of limited slots. But there is a small downside to this. There are still some downsides to this. What are the downsides? Well, if one day a certain disk fails, because all our physical devices have a lifespan, that's completely normal. All physical devices have a lifespan. They can't be used indefinitely. That's just unrealistic. Every device has a lifespan. Some might last a few years, while others can last 10, 20 years, or even longer. So when you reach the end of a device's lifespan, it's inevitable that some failures will occur, especially since the disks store important data for our entire system. If the disk is damaged. If the system disk is damaged, it could prevent your system from booting. If it's the data disk that's damaged, you might lose some data. So this brings up a problem. We can't guarantee the safety and integrity of the data on our disks. What should we do about this? At this point, as times have progressed, we have seen the emergence of our RAID. RAID refers to our disk array. The disk array. In addition, the array, what is its main function here? It's to ensure the integrity of our disks, to guarantee the integrity of the disks. There are actually many types of reads. Here, there are various kinds of reads. So here, how does it mainly work? It mainly works through... let me give a simple example. Let's take one. One of the models of RAID, for example. Read one. Read one. Its function is to combine 2 disks into a group. 2 disks form a group. Of course, it doesn't have to be just 2 disks. It can be 2 or more. It can be more than 2. After we group 2 disks together. So when we normally write data to the disk, we first write to one of the disks. Then the other disk also needs to write at the same time. And the data written is completely consistent, which is equivalent to what? It's like making a backup. We previously introduced the most basic method for ensuring data integrity in disks, which is essentially RAID. So this is a read one. We have 2 disks. For example, if we have 2 1TB disks, after we finish this week, the final size will actually only be 1 TB, while the other 1 TB is just a backup. Indeed, this does have a bit of what? A bit of wasted storage, but the safety and reliability are very high. With 2 disks, it doesn't matter which one you replace. We still have the other one to ensure the integrity of our data. This is the basic function of read. Of course, there are many more functions of RAID which will be discussed later. Then we just use an example to tell you that one of the main functions of this read is to ensure the integrity of our disk data. This is a basic feature of our disk array. Alright, let's wrap up our discussion here for now. If anyone wants to learn about Huawei certification technology or wants to get the Huawei certification question bank, please message me privately. You can also leave comments below the video for technical exchanges. Okay, that's it for today. Goodbye, everyone.